right, today we're looking at infinite limits, or limits to infinity. Now, these are not limits that equal infinity. These are limits that go to infinity. The first thing we have to talk about is indeterminate form. This is like a way of saying we don't have enough information the way it's currently written. There are a few types of indeterminate form. These are the two we're going to be focusing on today. You should have all of these written down for in the future when we'll come back and look at more indeterminate forms. But anytime you divide 0 by 0 or infinity by infinity, it's an indeterminate form. Now, a lot of times today, we're going to kind of treat infinity like a number, even though it's not. So for example, as x goes to infinity, well, this is going to end up equaling infinity. Now, as we said when we first started talking about limits, this would also mean it does not exist. We're just using this as a reference for now. If it goes to negative infinity, that's going to be negative infinity. If you have a negative number multiplied by x and x is going to positive infinity, then it would be negative infinity. If you have a negative infinity being squared, that would end up as positive infinity. And then if you have a constant over infinity, so you have a whole number over an infinitely large number, that's going to get closer and closer to 0. Right? These are some important facts about limits that'll help things out. Limits to infinity get real tricky when we look at rational functions. The one thing that we can look at is the horizontal asymptote. Because if you think about it, you have a horizontal asymptote. Well, that's always, even if it crosses, what it's going to come back to as it gets bigger and bigger. It's the end behavior of the graph. So remember some facts about horizontal asymptotes. We look at the degree. If the degree on top is bigger, well, let's start with the bottom. If the degree on bottom is bigger, so bottom bigger than top, then the horizontal asymptote is 0. If the top is bigger, or if the top and bottom are equal, then your horizontal asymptote is just dividing the leading coefficient, so leading coefficient divided by leading coefficient. And if the top is bigger, then you have a slant asymptote. Okay, so for example, this one, we have a degree of 1 and a degree of 1. So we can look at the leading coefficients. That's going to be 2 over 3. Now, this is only for limits to infinity, because that's what it's going to approach as x gets bigger and bigger. It approaches the horizontal asymptote. But for some, you might need a brute force method. Like, for example, this one, we have x cubed and x squared. That's a bigger degree on top. That means it's a slant asymptote. So we're going to use our brute force method to deal with this one. The brute force method is we look for the biggest degree on the denominator, so that's going to be x squared, and we're going to divide everything in the problem by x squared. Everything gets divided by x squared. And look at the new limit we have. We have 2x plus 3 over x minus 1 over x squared over 2 over x squared minus 5. Now, as x goes to infinity, this is going to go to 0, this is going to go to 0, this is going to go to 0, and we're left with infinity divided by negative 5. Well, infinity divided by a negative is still going to be negative infinity. Right? We could have also done that method here. Biggest degree of x is x there, and we have limit as x goes to infinity of 2 over 3 plus 4 over x. This goes to 0, we're just left with 2/3. Completely fine way of doing this. It's just one thing you need to keep track of, or one method you can use. So here are a few practice problems. A lot of them have nothing real special to them. Some of them you can look at, so same degree on top and bottom, so it's going to be 5/3. Some of them, once again, you can look at smaller degree on top. We said smaller degree on top means it's going to be a horizontal asymptote of 0. And some you might have to brute force. So this one you'll have to brute force it, limit as x approaches infinity. Biggest degree is x squared there, so 2 minus 5x over 3 minus 1 over x squared. That's going to go to 0. This is going to be 2 minus infinity, so a negative infinity on top, divided by 3, still a negative infinity, so negative infinity. Okay? We can also look at some with sine. These are really interesting because of the nature of sine. So since sine, if we think about the graph, this also happens with cosine, it alternates between, this is 1 up here on top and -1 on bottom. 1, -1. So that means on top, this is always going to be at most 1 and at least -1. So if we think about it that way, that's 1 to -1 divided by an infinitely large number. Well, what does that tell us is going to happen? Well, that means it's going to be alternating between 1 and -1 over an infinitely large number, so we're going to end up with 1 over infinity, or 0. Okay? Similar thing happens here, but this time we don't have a sine divided by x. Well, we do if we use the brute force method. Divide everything by x, and these cancel. We're left with limit as x goes to infinity of 1 over x over 2 plus sine x over x. This one's going to go to 0, and then doesn't matter what this one goes to. If it goes to 0 or infinity, you have 0 divided by a number. That'll give you 0. Okay? Now, technically, this will go to 0, same property we had up there. This is between 1 and -1 over infinity, so that's going to go to 0. So it's 0 divided by 2, but still, same idea. Now let's look at this one. We have infinity minus, or we have 2x minus 1 over x squared. As x goes to infinity, this is going to go to 0. That's just going to be left with infinity. Now, there's a question. Well, what if I did it wrong? Okay, well, let's combine the like term, or combine the fraction. Let's make this limit as x goes to infinity of 2x cubed minus 1 over x squared. Well, then we could feasibly do the brute force method, but we'd still go back to exactly what we had right here. So completely fine just to end up with infinity there. These are just a few more practice. We don't need to worry about those right now. More practice. Last ones we want to look at are these. These are a little bit different because you have to really think about what's going on here. I would recommend brute force method for these because you have to really think about what's happening. But let's look at brute force method. If you think about the degree on bottom, it looks like x squared. But technically, there's something else going on. There's a square root. So the degree on bottom inside the square root is x squared. But if we were to pull that out of the square root, what does that become? Well, it becomes x. So we're going to divide by x on top. We're left with limit as x goes to infinity of 1 over square root 1 minus, and then 1 over x squared. And as x goes to infinity, this is going to go to 0. And so we're going to be left with 1. Nothing too crazy there, except the second one. This one has a similar process. We divide it all and everything, and we end up with 1 over square root 1 minus 1 over x squared. We'd end up with 1, right? But there's an issue. This assumes that the square root is going to give us the same sign as the numerator. But it's not. A square root like this can only output a positive. But if we think about the values we're plugging in, up here we're plugging in positive infinity. So yeah, that doesn't change anything. It's a positive over positive. But on this one, we're plugging in negative infinity. So this is a negative number over what should output a positive, which means our answer needs to be negative. Now, we get that by just doing it and checking, but this happens anytime you have a square root on one part and an x on the other part, and you'll have to check that. And you're looking at limits to infinity. It's just how square roots work. They kind of mess us up some. All right, that's really all we're looking at today. For now, you can go ahead and work on your homework. Come and ask questions tomorrow if you need. Let me know if you need any help.